All right, so this next section is going to be 8.6 on solving rational equations. So when we have rational equations, the biggest thing that we've got is we have variables in our denominator that now we have to get out of the denominator so that we can solve this equation. Okay, similar to the complex fractions where we had fractions within fractions, I couldn't leave an x in the denominator. So same thing here, I can't solve it necessarily when it's in the denominator, so we need a way to get this out. So the first thing we're going to do, when we have a single rational expression on each side of our equation, the simplest thing we can do is to cross multiply. Excuse me. When we cross multiply, in this case, we're going to have -2 times x minus 4 equals 2 times x squared minus 2. Don't forget about those parentheses because it's the entire numerator times the entire denominator, and we need to distribute appropriately. So now I'm going to distribute on each side. So I'm going to have a -2x plus 8 equals 2x squared minus 4. So what I've got at this point is a quadratic. I want to move everything to one side of my equation so that I can try and factor and solve this. So when I do that, we're going to have 0 equals 2x squared plus 2x and minus 12. So in terms of factoring, right, check for a GCF. I do have one, it is 2. So I'm going to be left with x squared plus x minus 6. And now two numbers that multiply together to give me -6 and add to 1 are going to be 3 and -2. It's going to give me two solutions here. We're going to have x plus 3 equals 0 and x minus 2 equals 0. I have solutions of x equals -3 and solutions of x equals 2, right? Excuse me. So we do need to check and make sure that we have nothing in terms of a solution from my denominators. So in terms of my denominators, x could not equal plus or minus the square root of 2, and x could not equal positive 4. Both of these solutions should be good to go. So we are able to put a box around this at this point and call this an answer. Okay. When in doubt, check the answers back into the original equation, but these both should work here. The big thing we're looking for is division by 0. Okay. In this case, all right, here we've got -4 over 5 times x plus 2 equals 3 over x plus 2. So notice that my domain restriction x is not going to be able to equal -2 here. So I can cross multiply again. When I do that, we're going to have -4 times x plus 2 equals 5 times 3, we're going to have 15 times that x plus 2. So, oops, I wrote an x plus 5 instead of 2. All right, so when I go and distribute here, we're going to have -4x minus 8 equals 15x plus 30. So what I've got in this case is a linear equation. I want to get everything on one side of the equation and try and solve it. So if I add the 4x, I'm going to have a 19x over here. And if I subtract the 3, I'm going to have -11. Or x equals -11 19ths. Again, that is not part of my domain restriction. We are good to go with that answer. Now I come to this problem here. And with this problem, I've got a slightly different issue that I'm dealing with. I don't have a single fraction on each side of my equation. So I can either find common denominators and write it as a single fraction on each side, or I can look at all of my individual denominators and come up with a least common multiple of those denominators. So from the first term, I'm going to need a 4x. From the second term, I need a 4, which I already have. And then the last term, I need an x, which I already have. So my least common multiple here is a 4x. In this case, because they were monomials, I didn't have to factor anything. If it was written as a quadratic, you need to factor it first before you do this. So now what I can do is I can multiply through by this least common multiple, 4x. On the left, I'm going to have to distribute to both of the rational expressions here. So when I distribute to the first, I'm going to have 4x over 4x minus 3 times 4x over 4 equals, and on the right, I'm going to have 7 times 4x over x. So let's do a little bit of canceling here, all right? In the first term, the 4x and the 4x cancel, and because everything canceled, it leaves me with a 1. In my second term, the 4's cancel, leaving me with a minus 3x. And in my last term, the x's cancel, leaving me with 7 times 4, or 28. So if I subtract 1 on both sides, I have negative 3x equals 27. And if I divide by negative 3, I get x equals negative 9. Okay. Again, checking my domain restriction, x cannot equal 0 from these two terms. X equals negative 9. We are good to go here. This is a final solution for us. Okay. Another one very similar to that. Again, here x is not going to be able to equal 0. Our least common multiple. From my first term, I have an x. From my second term, I have a 2. And from my last term, I have a 2 and an x, both of which I already have. So I want to multiply through by that least common multiple. When I do so, and I'm going to reduce as I go. When I multiply to the first term, the x's cancel. I'm left with simply 2 times 1, or 2. When I multiply to the second term, the 2's cancel, and I'm left with x times x, or x squared. And when I multiply on the right, the 2x cancels, and I'm left with the x plus 4. Here I've got a quadratic, all right? So I need to get everything on one side of the equation. I'm going to move to the left, so my x squared is positive. So we're going to have x squared minus x and minus 2. Two numbers that multiply to negative 2 and add to negative 1 are going to be x minus 2 and x plus 1. So x minus 2 equals 0 and x plus 1 equals 0. And solutions will then be x equals 2 and x equals negative 1. Okay. Again, none of these hit our domain restrictions. We should be, I don't know how I made an arrow, we should be good to go here. Right. And the last one, okay, in the last equation, I've got quadratics. I need a factor, especially this middle piece, first before I can do anything. So here we're going to have a 2x over x plus 5 minus, I can factor the numerator. I don't know if I need to or not. Let's just leave it the way it is. X squared minus x minus 10 over x plus 3 times x plus 5 equal to 3 over x plus 3. So if I look for my least common multiple, from the first term, I need an x plus 5 as a factor. From the second term, I need an x plus 3 and an x plus 5, which I already have. And the last term, I need an x plus 3, which I, again, already have. So what I want to do is I want to multiply through by this least common multiple on both sides of my equation. So when I do that, we're going to have the following. In the first term, the x plus 5's cancel, so I'm left with 2x times x plus 3. In the second term, both cancel, leaving me with negative x squared minus x minus 10. And in the last term, the x plus 3's cancel, leaving me with 3 times x plus 5. You might notice I put parentheses around this here because I'm subtracting the entire fraction. I need to distribute this negative to each term yet. Okay, and since everything canceled out, there was no other multiplier other than negative 1. So let's distribute. We're going to get a 2x squared plus 6x minus x squared plus x plus 10 equals 3x plus 15. Again, I'm going to have a quadratic here. I want to get everything on one side of my equation. So we're going to combine like terms, move to the left. So 2x squared minus x squared is x squared. On the left, if I add, I'm going to have a 6x plus x, or 7x. And when I subtract the 3x, we're going to have a 4x. And when I subtract the 15, I'm going to have a negative 5 equal to 0. So two numbers that multiply to -5 and add to +4 are going to be a +5 and a -1. This is going to give me solutions then. We're going to have x plus 5 equals 0, or x equals -5, and x minus 1 equals 0, or x equals 1. Now, if we go back and look, my domain restrictions from my denominator, x could not equal -5, and x could not equal -3. Well, I've got a -5 right here. If I plug that back into my equation, I'm going to get division by 0 in this fraction and in this fraction, which we're not allowed to have. So what I know is that the x equals -5 is extraneous. I don't want you to erase it. I want you to put an x through the equal sign and write ext underneath for extraneous, and put a box around the whole thing, because you should have found that solution, but then you should also have found that that solution is extraneous, in this case because of division by 0. All right, give these a try, and we'll see you guys tomorrow.